All right, so now we're taking a look at a story problem. Number 14, it says a camera attached to a kite is filming the damage caused by a brush fire in a closed-off area. The camera is directly above the center of the closed-off area. And so a person standing 100 feet away from the center of the closed-off area. Here's the ground. Here's the closed-off area. I'm going to call that C. Here's the person. They're 100 feet away. The angle of depression from the camera to the person flying the kite is 25 degrees. So the kite's going to be right here. Here's the person. The angle of depression, here's where the camera is. I'm going to call that just point A, because I already have point C for the closed off area. But here's the angle of depression. Angle formed by, this is called the line of sight. That's parallel with the ground. And this is the angle of depression. That's 25 degrees. Since these are parallel, the angle of elevation that the person looks up to the camera at would be the same, because those are alternate interior angles. And then you want to know how long the string is on the kite. That's this length right here. It's opposite C here. This has to be a right angle. So I'm going to call it lowercase c. And then you have to figure out exactly what trig function that you need to use to find the length of the string, which I called C. Okay, here's your 25-degree angle, 100 feet. That's adjacent to the 25-degree angle. C, that's the hypotenuse. So only one of the functions uses both adjacent and the hypotenuse. Can you figure out which one it is? It should be cosine, the ka part of SOHCAHTOA, adjacent and hypotenuse. But you take the cosine of 25 degrees, cosine is adjacent, so in this case 100, over the hypotenuse, which is C. If you notice, for this equation that we have, the variable is in the denominator. So if you don't want to use this equation with the variable in the denominator, you would have to find this angle here. It's a complement of 25 degrees. So the complement of 25 degrees is going to be 65 degrees. Now, the 100 is not adjacent, it's opposite. And then C is the hypotenuse. So if you try to set up an equation using the 65-degree angle, you'd set up opposite over hypotenuse, which is sine. Sine of 65 degrees equals the side opposite 100 over the hypotenuse. Dang it, we end up with the variable in the denominator. So here's one of the problems I was kind of talking about earlier, where it's unavoidable that you have the variable in the denominator. So we need to solve one of these equations. Kind of doesn't matter which one, you should get the same value of the variable in the denominator. Okay, so if I solve this first one, we first need to multiply each side by C, and then it's C times the cosine of 25 degrees is equal to 100. We divide each side by the cosine of 25 degrees. And then you'd have to use your calculator. 100 divided by the cosine of 25 degrees should get about 110.34. What does it say? What to round it to? It doesn't. So C, the length of the string, if I round it to the nearest tenth, is about 110.3 feet for part A. And then on part B, now you have the string on the kite is 200 feet long. You want to know how far away the person flying the kite must stand from the center of the closed-off area, assuming that same angle of depression is 25 degrees. So the angle of depression is actually right here, 25 degrees. Okay? Don't make the angle of depression right here. That's a common mistake that people make. But that means this angle is 25 degrees because those angles are alternate interior angles. And you want to figure out this distance right here. I'm going to call it D, that the person must be away from the center of the closed off area. So if I'm going to use the 25-degree angle, D is adjacent, 200 is the hypotenuse. And so only one of your functions uses adjacent and hypotenuse, kind of like the last example, or part A, it's still cosine. So the cosine of 25 degrees is equal to the side adjacent, D, over the hypotenuse, 200. If we solve this for D, we multiply each side by 200. So D is 200 times the cosine of 25 degrees. And then we could evaluate that on our calculator. 200 times the cosine of 25 degrees, then the person must be, or the distance is about 181.3 feet.